Alright, it's time to get ready for our Unit 1 test. And so on number 1 and number 2, it just wants us to sketch the inverse of the function. And so what we'll be doing is we'll take each of these points, switch them, plot them, and then we'll graph it. So this first point is 1, 2, 1, 2, 3, 4. And so when we flip it, it's going to be 4, 2, 1, 2, 3, 4, 1, 2. So these are going to be the original points, and then my inverse points over here, so I'll label them f of x and f negative 1x. The next one is negative 1, 1, 2, 3, 4, 3, 4, negative 4, 1, 2, 2, 3, 4, 5, 6, negative 6, negative 2, negative 8, 5, and negative 10, 1. And so it's going to go to 4, negative 1, 2, negative 4, negative 2, negative 6, 5, negative 8, and 1, negative 10. And so we'll plot all these points, so 4, negative 1, and we'll connect them in order as we go. Let's see, 2, negative 4, negative 2, negative 6, so 5, negative 8, 1, 2, 3, went down negative 8, and 1, negative 10. And when you look at these two graphs, they should reflect over this dashed line that I'm making. That is the line y equals x. These should be reflections over this line right here, which it appears to be. Alright, number 2, we'll do the exact same process. And so we'll start right here. Let's see, 2, 8, negative 1, 1, 2, 3, 4, 5, 6, negative 3, 3, negative 6, 1, negative 7, negative 2, and negative 10, negative 4. And so we'll flip them to 8, 2, 6, negative 1, 3, negative 3, 1, negative 6, negative 2, negative 7, and negative 4, negative 10. Alright, so 8, 2, 6, negative 1, 3, negative 3, 2, negative 7, alright. So just take each point, flip them, and that's it. Next off, we're going to find the inverse of the following. This is just like we did on the previous. All the points are just going to switch. So 112, 5, negative 3, 3, 4, 7, 10, negative 12, 6. On this one, we're going to go through the process to find the actual equation. So we're going to switch our x and y, and now we'll solve for y. So we're going to subtract 1 on both sides. X minus 1 equals 5y, and then we'll divide everything by 5. So y equals, it's going to be 1/5 x minus 1/5. Again, we're going to switch our x and y, so x equals 7 minus 2y. And now we'll solve, so we're going to subtract 7 on both sides. X minus 7 equals negative 2y, and we'll divide everything by negative 2. So this becomes negative 1/2 x, because x divided by negative 2, and then plus 7/2. And then my last one, number 6 right here on the front, we'll switch my x and y, so x equals y plus 4 squared minus 3. We're going to get rid of the minus 3 first. So x plus 3 equals y plus 4 squared. This plus 4 is inside the parentheses, so I can't get rid of it quite yet. We're going to get rid of the squared by taking the square root of both sides. And so we're going to plus or minus square root of x plus 3 equals y plus 4. And now we'll get rid of that 4 by subtracting 4. But we can't subtract 4 to the 3 because the 3 is on the inside of the square root, 4 is on the outside of the square root. And that's my answer right there. All right, we'll flip on over. All right, so we're going to graph the equation that's given. We'll graph the line y equals x, and then we'll reflect it across the line. So on the first one, it's linear. You could use your calculator if you want to. I'm going to use my slope and my y-intercept. And my y-intercept is 2, and my slope is 1/4. So I'm going to go up 1 and over 4. Up 1 and over 4. And so I don't have a ruler on me right here, so I'm just going to make the best line that I can going through these points. And then we're going to do the inverse, which is going to reflect over this dashed line y equals x. And so to find that inverse, we could find the equation of the inverse or just take the points and flip them. So my original points were 0, 4, 3, and 8, 4. And so I'll flip those. We're going to have 2, 0. So this was my f of x, my original. We're going to start with 2, 0. We're going to go to 3, 4. And then we'll go 4, 8. Again, I'll make the best line I can without a ruler. And so this is my inverse right here. I'll label it with my inverse notation, f negative 1x. And that is all that we needed to do. Number 8, I'll do the same thing. And so I'll make a table on this one. You can use your calculator. I'll just use the points -2, -1, 0, 1, 2. When I plug 0 in for x, 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. On the other side, -1 squared is 1 plus 1 is 2. -2 squared is 4 plus 1 is 5. So here's my table for my original, and it should, since it's squared, be a parabola. It should be a U. So I'm going to start at 0, 1, and then 1, 2 on both sides, -1, 2 as well, and then 2, 5. And same thing on the other side, -2, 5. And so here's my parabola. And now we're going to reflect this parabola over the dashed line y equals x. And so I'm going to take these points and flip them. So instead of -2, 5, I'm going to go to 5, -2. 2, -1. 1, 0. 2, 1. And 5, 2. And so here's my original graph over here and my inverse right here. Number 9, we're going to verify that these are inverses. There's a couple ways that we can do it. I'll show both ways. On number 9, I'll do the f of g of x, and we'll see, does this equal x? That's what it should equal. When you do f of g of x, it should equal x. And so we're going to plug in this function in for x and check it. And so we're going to have f of g of x. We're going to have the 7. In place of the x, we're going to put in the whole thing. So x minus 15 over 7 plus 15. Right here we're multiplying 7 and we're dividing 7, so these 7's actually cancel out. We're left with x minus 15 plus 15. These cancel out and you're left with x. And so our question we were trying to get is, does this equal x? Yes, it does. So my answer on number 9 is yes. So that's one way of doing it, the f of g of x. Number 10, another way of verifying if they're inverse is we can find the inverse of this and see if it equals this, or vice versa. And so y equals 4x minus 16. Switch the x and y. And then we'll solve for y. So we're going to add 16 over. And then we'll divide by 4. And so y equals, that's going to be 1/4 x plus 4. And we're going to see if this matches 1/4 x plus 4. Yes, they do match. And so that's another way you can do it. Either way is fine. Number 11, I'll show both ways. And you can see which one you prefer. So the first way, I'll find the inverse of this. X equals, I'm going to switch my x and y. And then we'll subtract 1 over, so x minus 1 equals 3y. And then we'll divide everything by 3, so y equals 1/3 x minus 1/3. Looking over here, nope. So my answer is going to be no. But I'll also show the other way in case you're wanting to see it. So g of f of x. We'll plug this in and see if it works. We're going to plug in this equation in for x right here. So 1/3 3x plus 1 minus 1. The minus 1's from there, right there. And so we're going to distribute this 1/3. And so 1/3 of 3 is just 1x. 1/3 of 1 is 1/3 minus 1. These don't cancel out. It becomes negative 2/3, which is not x, and so no, it's not. These are not inverses of each other. And so I showed both ways. You can choose which way you want to do on the test. All right, number 12. You're going to have a matching section on this test. You need to be familiar with all of these functions. The absolute value starts with a v. It makes a v as well. The equation is y equals, and it has the absolute value bars around the x, and it looks like a v. And so just remember, absolute value, v, makes a v. Next one, the quadratic, you should be pretty familiar with from Algebra 1. Y equals x squared, and it makes the parabola, makes the U-shaped. The square root, y equals the square root of x. Because we can't take square roots of negatives, it's going to start at 0, 0 because the square root of 0 is 0. I can't do any negatives, so it's going to go up and to the right in a curved motion like this. And square roots are the only graphs that have an absolute starting point. All the rest of the graphs are going to continue going left and right. This is the only one that just stops, right, or has a good starting point. Number 15, my rational. Think ratio. A ratio is a fraction, so it's going to be this fraction, 1 over x. And it's my funky looking graph that has the little parabolas in quadrants 1 and quadrants 3. And so it includes everything except for the x and y axis. The cubic, y equals x cubed. This is my vertical little snake looking thing. And so it's vertical going up and down. The cube root is the opposite. And so the cube root of x, it's the same graph but horizontal. The exponential, it's an exponent. So my x is in my exponent, y equals 2 to the x. And I'll just do the growth. It also could be y equals 1/2 to the x power. But I'm just going to stick with the growth one right here. And this is the growth graph. It's growing as you go to the right. It does not touch the x-axis, though. There's another asymptote down there. And the logarithmic looks kind of like the square root graph. It also looks like the exponential graph. The difference between the logarithmic graph and the square root graph, square root has a starting point. Logarithmic keeps going down forever. And so remember that. All right, going on number 20. We're going to list all the transformations. So we're going to have a vertical stretch by 3. We're going to go left 2. And we're going to go down 5. Alright, at the next one, number 21. It has the negative in front. Anytime you have the negative in front, that is going to be a reflection over the x-axis. This number 1/3 is between 0 and 1, so there's going to be a vertical compress. The -7 is underneath the square root, so it's going to go right 7 and up 2. We've got a negative in front again, so it's going to reflect over x. And down 1. -4 is inside parentheses, so right 4, and that's it. Alright, going on, numbers 24 through the rest. On number 24, I'll do both the interval and the inequality on several of these, but my domain, it starts at -3 and it doesn't touch -3, so it's a parentheses, but it has an arrow, so it's going to go all the way to infinity. And so that's the interval. That inequality form would be x is greater than -3. My range, the lowest point is -4 and it touches -4, but it has the arrow again, so it's going to go all the way up to infinity. And we always put parentheses around infinity, and so y is greater than or equal to -4. There's my inequality. 25, it's going forever both directions, so I'm just going to put all real numbers. That's good for both of them. Again, it's going forever down and up, so it's all real numbers. So it's forever going left and right and up and down. My domain on this one's hard to tell whether it's stopping at the 1 or if it's going to keep going. I'll say it's gonna stop at this 1. We'll make this an asymptote right here where it doesn't touch that 1. So my domain is going to be from 1 to 3, not touching either of them. Doesn't touch the 1. It also doesn't touch the 3. My inequality would be x is greater than 1 and x is less than 3, both of those. For my range, the lowest value is -1 and it doesn't touch -1, but it's going to go forever up, and so y is greater than -1. Alright, on the next one, number 27, my domain, it doesn't touch -3 and it doesn't touch 4. Those are the furthest left or furthest right. My inequality form, x is greater than -3 and it's less than 4. My range, the lowest point is -1 and it doesn't touch all the way up to 4. And so my range would be y is greater than -1, less than 4. Domain on this one, the furthest point is -3 and it touches -3 all the way to 2 and it doesn't touch. So x is greater than or equal to -3 but less than 2. My range goes from -5 without touching all the way up to 2, and it includes that one. So my y is greater than -5, less than or equal to 2. And last one, my domain goes left and right forever, but my range starts at 0 and goes up to infinity, and so y is greater than or equal to 0. All right, I hope everybody's ready for this test.